Hello students, welcome to the problem solving session on game theory. In the last class we have discussed about the theoretical part of game theory. Today we will discuss about the problems on game theory. Let us go with the example. Does the game 8 minus 1 1 3 have saddle point? So here the game is written in the form of matrix notation. So rewrite the game once again. 8 minus 1 1 and 3, and we will solve this problem by max-min and min-max principle that I have discussed in the previous class. That is, there are two principles in game theory. First one is max-min and min-max principle, and second one is dominance principle. Let us solve the first method. Let us solve this example by first method. So here, according to max-min and min-max principle, the condition is the minimum payoff in each row is circled. So go to first row, 8 and minus 1, which is minimum among 8 and minus 1. Minus 1 is minimum. So just you circle it. Then go for the second row, among 1 and 3. Again 1 is minimum. Then go for circling 1. Then second point, the maximum payoff in each column is boxed. So then column wise, 8 and 1, which is maximum 8, you just box it. And in the second column, minus 1 and 3, maximum value among minus 1 and 3 is 3. Okay, so you just box it. Okay, now since none of the payoffs is circled as well as boxed, the game does not have a saddle point. So saddle point means one of the value in the payoff matrix must be circled as well as boxed. Then only we will get a saddle point and value of the game. Here we won't find any one of the value which is circled as well as boxed. So this particular example does not have a saddle point. Okay, now second question. Two persons A and B play a game as follows. Both of them simultaneously place a 5 rupee note or a 10 rupee note on the table without knowing which note the other will keep. If the notes are of the same denomination, player B will take both the notes. Otherwise, A will take both of them. I mean, here both the players, player A as well as player B, play a game. So both of them keep a 5 rupee note or 10 rupee note simultaneously without knowing to each other. If both of them are 5 rupees, if notes are of the same denomination is nothing but if both are 5 rupees, if both the players keep 5 rupees unknowingly, or if both the players keep 10 rupees unknowingly, then player B will take both the notes. Otherwise, A will take both of them if they are of different denominations. Means if one player keeps 5 rupees, another player keeps 10 rupees. Or if one player keeps 10 rupees and other player keeps 5 rupees, that is known as different denominations. Then A will take both of them. Write down the payoff matrix of A. Verify whether the game has saddle point. Okay. Now, here we have to frame the matrix. Here we are writing payoff matrix of player A. So player A should be written on row side and player B should be written on column side. If you are going to write the payoff matrix of player B, then you have to write player B on row side and player A on column side. Here we are writing player A's payoff matrix. Okay. Now, unknowingly both the players keep 5 rupees and 10 rupees notes. So here I will take the courses of action of player B and courses of action of player A. So player B keeps 5 rupees and 10 rupees. Options. He may keep 5 rupees or 10 rupees. And here also player A may keep 5 rupees or 10 rupees. Okay. Now you go for matching. 5 and 5. Both are same denominations. Okay. 5 rupees and 5 rupees. both are same denominations, and the condition is if the nodes are of the same denomination, B will take both the nodes. So if the nodes are of same denominations, B will take both the nodes. Means here we are writing player A's payoff matrix. And in this matrix, you have to write profit of player A as well as loss of player A. You keep it in mind. We are writing player A's payoff matrix, and here you have to write profit or loss of player A. So here 5 rupees and 5 rupees both are same denominations. If both are same denominations, then player B will take both the nodes. Player B will take both the nodes. Then what happens? It's a loss for player A. Right? Here we are writing profit or loss of player A. Okay. Then how much loss of player A it is? How much? It is -5, because player A loses 5 rupees. Player A has to pay 5 rupees to player B. If both the players keep 5 rupees on the table, then player B takes both the nodes and player A loses his 5 rupees. Then here you have to write -5. Then go for 5 and 10. Here both are different denominations. Player A keeps 5 rupees and player B keeps 10 rupees. Both are different denominations. If both are different denominations, then A will take both of them. So here both of them different denominations. Then player A will take both the notes, that is 5 rupees and 10 rupees. So what is the profit for player A? What is the profit for player A? 10 rupees profit. Already he has 5 rupees. Here just we have to concentrate on profit and loss of player A. Here in the first cell, player A loses his 5 rupees. So here you have to write -5. Here player A gains 10 rupees. Then here you have to write +10. Then in the same way 10 and 5 both are different denominations. So how much player A gains? 5 rupees. 5 rupees of player B, player A takes. Okay. Then the profit for player A is +5. Then both are same denominations, 10 rupees and 10 rupees. So player A loses his 10 rupees. So here you have to write -10. Whether it is profit or loss, you have to write player A's matrix. If you are going to write player A's matrix, if you are writing player A's matrix, then you need to write profit and loss of player A only. Then go for max min and min max principle. Row wise -5 and 10. Minimum value is -5, circle it, and again in the second row, which is minimum among 5 and -10, minimum is -10. Then column wise, maximum value is 5, -5 and 5, maximum is 5, box it, and in the second column 10 and -10, maximum value is +10. Here there is no saddle point. Okay, the solution has no saddle point because here any one of the value of matrix A doesn't coincide. That is, no one value of matrix A is circled as well as boxed. Hence, the given solution has no saddle point. Okay. Now, let us move with the third example. Player A writes one of the numbers 1, 2 and 3 on a piece of paper and keeps the figure hidden under his palm. Without knowing which number he has written, player B writes one of the numbers 2 and 5 on the same paper. Then the two numbers written by the two players are added. If this sum is odd, A pays 100 rupees to B. Otherwise, B pays 200 rupees to A. Write down the payoff matrix of A. Does the game have saddle point? So again, here in this example also, we need to write payoff matrix of A. So write down player A on row side and player B on column side. Then player A writes one of the number 1, 2 and 3 on a piece of paper. So the possibility, he may write 1 or 2 or 3. Okay, then player B writes 2 and 5 on the same paper without knowing each other. So the possibility for player B is 2 and 5. Then here the condition is what? The two numbers written by the two players are added. If the sum is odd, A pays 100 rupees to B. See here, 1 and 2. First cell, first row, first column. And the number for player A is 1 and the number for player B is 2. 1 and 2. If you add 1 and 2, 1 plus 2, you will get 3. 3 is an odd number. 3 is an odd number. Okay. Here the condition is, see, two numbers written by the two players are added. If this sum is odd, A pays 100 rupees to B. See, 1 plus 2 is 3. 3 is an odd number. Okay. So here we have got odd number by adding 1 and 2. And if we will get odd number, then player A should pay 100 rupees to player B. And how much is the loss for player A? He has to lose his 100 rupees. So that is, you have to write minus 100. Then go for second. 1 and 5, that is 1 plus 5 is 6. 6 is an even number. Okay. See, the condition is the two numbers are added by the two players. If this sum is odd, A pays 100 rupees to B. Otherwise, B pays 200 rupees to A. So by adding two numbers, you may get, there are only two options. We will get even number or odd number. So in the first case, we have got an odd number by adding 1 and 2. And in the second case, 1 and 5, we have got an even number. So 1 plus 5 is 6. Then B pays 200 rupees to A. So it's a profit for player A. So you need to write plus 200. Then in the second case, second row, 2 plus 2, 4. Again, it's an even number. Then B pays 200 rupees to A. So write down plus 200. Then 2 plus 5, it is 7. 2 plus 5 is 7. 7 is odd number. So if the sum is odd number, then A pays 100 rupees to B. Then there is a loss for player A. So write down minus 100. Then 3 plus 2 is 5. 5 is an odd number. So A should pay 100 rupees to B. Write down minus 100. Then 3 plus 5 is 8. That is, 8 is an even number. So B pays 200 rupees to A. That is plus 200. So player A, you have to write player A's payoff matrix. And you have to write either it's a profit or loss. You have to write player A's matrix only. So again, go for max min and min max principle. Row wise, circle it. In the first row, minimum is minus 100, circle it. In the second row, minimum is minus 100, circle it. In the third row, minimum is minus 100, circle it. Column wise, 200 is maximum, square box. And in the second column, here we will get 200 and 200 twice. So box it. And here also we can box it. Either this 200 or this 200. Option is yes. Or else you can box both the 200s. So here also any of the value or no one value in the payoff matrix is circled as well as boxed. Hence game has no saddle point. Then fourth one, players A and B have a coin each. Each of them simultaneously exhibit either head or tail. If both exhibit head, player A pays 10 rupees to B. If both exhibit tail, player A gives 5 rupees to B. Otherwise, B gives 4 rupees to A. See the condition. Player A and B have a coin each. Both of them toss simultaneously. Then, if both exhibit head, player A pays 10 rupees. If both exhibit tail, player A again gives 5 rupees to B. Otherwise means different coin. Different denominations. That is, one player may get head and other player may get tail. Otherwise, B gives 4 rupees to A. Formulate the game. Verify whether the game has saddle point. If so, write down the solution. Then player B, possibility head and tail. Player A, head and tail. Here also we have to write payoff matrix of player A only. So now go with head and head. If both have, see here the condition, if both exhibit head, player A pays 10 rupees. Here both exhibit head. Player A pays 10 rupees to B. So it's a loss for player A. So minus 10. Here head and tail. Okay, here player A exhibits head and the player B exhibits tail. Then here player B gives 4 rupees to A. So it's a profit for player A. So write down plus 4. Then tail and head. Tail and head. Here player A exhibits tail and player B exhibits head. So player B has to pay 4 rupees to player A. It's a profit for player A. Write down plus 4. Then tail and tail. If both exhibits tail, player A gives 5 rupees. Both exhibit tail, player A gives 5 rupees to B. It's a loss for player A. You have to write minus 5. Then go for max min and min max principle. Circle row minimum and box column maximum. Minus 10 and 4, minimum value is minus 10, circle it. 4 and minus 5, minimum value is minus 5, circle it. Column wise, maximum is 4, box it. And in the second column, maximum is 4, box it. The game has no saddle point.